Hello, now I'm going to introduce you the offline concurrency patterns for enterprise applications. And what is this about? So you have the different layers of an enterprise application, and what you want to deal here is about how do you deal with transactions. Why? Because what characterizes an enterprise applications is the simultaneous the simultaneous accesses of different users or different requests that simultaneous access this, and you want to preserve the consistency of information. Usually, in a system like this, you rely on the database management system, and you rely on the transactional support of the database, the transactional system. But the problem that you have to address here is that these transactions that occur, that you're going to call them business transactions, actually have a long duration. And if they have long duration, during their execution, they do different accesses to the database. So one solution would be to open a system transaction in the database and keep it open for all the execution of the business transaction. But these will result on unnecessary locking, unnecessary contention on the resources that you are accessing in the database. So in order to improve performance and to increase the amount of concurrency that allows different users to access, what you're going to do, you're going to split your business transaction into a set of system transactions. And each one of these system transactions uses an exit behavior in the database. But now you need to deal with concurrency control on your side. So what you need to do is that when you finish the business transaction, you need to guarantee some level of consistency in the database. So how do you guarantee that level of consistency? Well, basically, you need to implement what is called offline concurrency control. It's offline because it's outside the context of the database, so you have to implement it there. And these patterns are about how can you implement it. And the main idea here is how do you consider the semantics of the application to deal with that? So there are basic two solutions. One is that the transactional management that you're going to implement is completely agnostic of the semantics of your application. In that case, it's nice because you can ignore, when you implement the business logic, you can ignore most of the behavior in the database, but sometimes it's not possible. And so what you need to do, you need to consider the type of structures, the semantics of your application, and in order to define, for instance, what is the level of granularity that you're going to define in your model, or to identify if there are a particular cycle of contention that can take you to a deadlock, and decide that in your application you always lock or access the objects by a predefined order, for instance. So the patterns are a bit to discuss these aspects, and in some sense bringing to the development of the business application some things that sometimes are completely hidden by the transactional management infrastructure. Okay? Of course, these patterns actually can be used to implement transactional management infrastructure. So you can have a transactional management infrastructure here in memory that basically use these patterns to guarantee some level of quality. Okay, and actually this is what is done by the transactional behavior supported by GPA, for instance. So let's go for these patterns and just go do a quick walk through them. So there are 4 patterns: optimistic offline lock, pessimistic offline lock, coarse-grained lock, and implicit lock. So the difference between optimistic and pessimistic is in one you verify. So when you verify if you can do something, And in another one, in the pessimistic locking, what you do is that you prevent the conflicts to occur. So in the first, in optimistic locking, you the the conflicts can occur, and afterwards you verify. So afterwards you may abort if things didn't occur as you expected. In this case, conflicts will never occur. Basically, just prevent conflicts to occur. Why do you have two different policies? Usually because, for instance, if in a system where you have a lot of reads and very few writes, optimistic is a better solution because most of the transactions are not going to have conflicts. So in a very few situations, you're going to abort after we have done the work, which is not nice if you have done some work and then you need to abort, so you need to redo things. But if this occurs very, very seldom, then okay, it's it's the right solution. But if you have a lot of conflict, so if the probability of aborting something is high, it's better to follow a pessimistic offline lock. That basically what it does is that just before you access guarantees that everything is okay and that things is not, there will be no conflicts due to your invocation. Okay, of course, this is much harder to implement because you have deadlocks, and then you need to do have a lot of intelligence to deal with it. There are several techniques to deal with it. Well, for example, one of the simplest techniques is just lock everything at the beginning. Okay, so then there's no deadlocks. But sometimes this is difficult. By locking at the beginning is easier if you use a transaction script, but if you have a domain model, it's quite impossible to do it because actually at the beginning you don't know all the objects that you are going to touch. While if you have a transactional script, maybe you can know what is going to be inside, which entities you're going to access. Okay. These ones are easier it's easier to implement. Usually what you do is just so you create a copy or you create versions of the entity. So basically what happens is that you have a version that is the real version, and when you access, you create a version, you work with your version, and when you commit, basically you write your version back to the database. And that moment you discover if there was a change in the number of versions, and if there are a change in the number of versions, it means that other transactions just occur and change it, and then there's a conflict, then probably need to abort. Okay, so then you have the coarse-grained lock, and here is where you bring to these techniques the semantics of the domain. So you can define locks. The granularity of locks depends on the semantics of what you are doing. Okay, so the point here is that if you discover that there are a group of objects, for instance, an aggregate, that every time you change one element, this implies that all the other elements are semantically implied in this change. You may define a granularity lock that means that, well, I can look at the consistency of this as a whole. I don't need to look at it as parts. Of course, sometimes the way you define these granular locks is basically to make these implementations easier because if you have higher granularity, the number of possible combinations is smaller, and then you can manage it. So the minimal case is just to have a granularity lock of all the database or all the information, which would make no sense. But then, okay, these have trivial implementation. And the final pattern that you're going to read is about implicit locking. And implicit locking is the problem that you should not forget to lock the objects. So if to avoid to forget, it means that it's good if in your system you do not trust the developer to lock things, so that the lock is implicit. So as soon as you touch an object, the object locks itself. This is important because one of the big prices you pay if you forget to lock something is that data becomes inconsistent. And the effort to clean data that is inconsistent is too high. for two reasons. Because first, it's difficult to understand what happened, because basically it's an inconsistent state. So you look at the data and it's difficult to understand that what is not consistent there. And the second thing is that as time passes and you have that inconsistent data in your database, and other transactions start executing on top of this inconsistent data, it generates more inconsistent data. So it can be a big problem. So the best way is to implement a policy where you do implicit locking, so that there you guarantee that everything is locked, and then you don't and of course, if you have correct implementations of optimistic offline lock or pessimistic offline lock, then your information will not be inconsistent. Okay, so enjoy and reading these patterns.